Alright, so an important issue that we need to address is the GFIs and how they can be a real problem to you. GFIs, what is their purpose? They're known as GFIs, RCDs. GFCI stands for Ground Fault Connection Interrupter. RCD stands for Residual Current Disruptor, I think. Depends on which region you're in, what they're called, but ultimately you'll recognize them as one of these plugs that has little buttons on the front of it. So what is the purpose of this? I'm going to give you a link to a video from the infamous Electro Boom that discusses the functionality of a GFCI or RCD in full detail, including some testing. In fact, I think Big Clive also did some of this stuff, but my point to you today is about how you should not use them at a tower site. So what is the purpose of this device? This device here is specifically for human protection, well, just protection in general. So what it'll do is if it senses current to ground, or basically connection from ground to neutral, neutral to ground, or from, well, basically from any of the pins to ground. If it sees energy hitting ground on this thing or anything a little off, it will trip. And when it trips, it cuts off some power. So there's no power coming out of this, and there's no power going downstream of it. So you've got two interfaces on here. You've got your line, which connects directly to the power in from the breaker panel, and your load, which carries on further down the circuit. So this is this fault, so it'll actually cut the power to all the direct downstream outlets. Now, why is this a problem for an ISP or anybody else in telecom? In telecom, we need reliability. So you find us using UPSs or DC power systems to typically keep our sites online, right? Something which we constantly deal with is not only lightning, but ESD. Now, ESD can happen in the wintertime. An example of that is when the air gets very dry. So if the air gets too dry and you have like a snowstorm around a tower, around something along those lines, what you're going to actually find out is that that little cloud of snow can generate quite a little bit of electricity, and it'll discharge. Okay, so that'll discharge your equipment. If it's not grounded, it acts just like lightning. It's just localized and a lot less power. Something else which can happen when it gets very dry out is that your body becomes a conductor, or not a conductor, a capacitor, or what's the other term? Not if I can remember. My brain is fried. But anyway, you can become basically a power source. You can store high potential energy, like a few thousand joules of energy, and you can go and poke your friend and zap them, right? Well, it's the same thing with your equipment. So if this little device here picks up any kind of a ground fault, it will trip. That could be many things. You might say, well, if it trips, then it's, that's a good thing, it's doing its job. Yeah, but in telecom, you can get false hits. As an example, as I just mentioned, lightning and any kind of static discharge, okay? So if it's very, very, very dry outside, let's say, and for some reason you get some type of a fault, just a minor instantaneous fault across the neutral or the ground on this thing, it will trip it. And if you don't have proper site monitoring, like a proper supervised UPS or supervised DC plant, that'll take your site down, which means your customers are going to go offline, which means hell. It's going to be a nightmare for you. It's not going to be great. Everybody's going to be unhappy, right? So you don't want to have these in your plants at all. I printed off a little diagram here. I'll have put this in the description, but here's it up close. Actually, it's probably not much bigger. Let's see. Yeah, that doesn't do much bigger. It's almost identical, same size. Well, that was kind of pointless, wasn't it? That is everything that I just explained right there. That is your GFCI, your RCD right there, okay? So the whole point of the story, folks, is that your enclosures should be properly grounded, which is going to protect you from any kind of electrocution for the most part. It will protect all your equipment, or sorry, I should say decrease the possibility that it's going to get fried, making this somewhat unnecessary. So if you're running your site, you should not have a GFCI in there. You should have a direct to breaker receptacle, and everything needs to be grounded properly. Okay, so that being said, what happens if you have one of these? You call an electrician, you get him to swap it out. Now, where are these things needed? Well, typically according to code in my neck of the woods, which is Ontario, Canada, these have to be installed anywhere within 1 meter of a sink or a wet location. So like bathtub, washing machine, any of that stuff, right? But the code does allow for exceptions where it's for commercial or industrial or agricultural purposes, where this is not necessarily needed for human protection. It's actually going to be like an appliance or high usage device, a heavy duty device that's going to be plugged into it. They say no, right? Now, if you're in a pinch, I do not recommend this at all. But say that you're in a situation where your tower's in the middle of nowhere, okay? Or your site, your POP, is in the middle of nowhere, and you've got one of these guys and it faults, it fails. Something that can get you by temporarily until you can run into town and get another plug is you can take the leads from the line in and you can switch them over to load. That bypasses the GFCI circuitry and essentially livens up both these plugs, these receptacles, regardless of the state of the GFCI or RCD circuitry. So with that being said, remember that is not a permanent measure. If it's like the middle of the night and you've had a run out because your site's gone offline, if you are qualified to do so, you can flip it around, swap the wires around on it, put it back in, and that'll get you by until morning, until you can go into town, buy another one, hook it up, okay? Thank you for watching. Don't forget to check out the Patreon and the Facebook page. You guys make all this possible, and as you can see, everything's improving all the time thanks to the interest that you guys have shown me in the channel. So don't forget to like and subscribe, tell your friends, and leave what you want to see in the comments below, okay? Thanks, guys. We'll see you later. Ciao.